my secondary school days, isotope was the second outstanding word I had in my chemistry class after hypothesis. It was funny. It was strange. Today we are going to discuss isotopes. What are isotopes? Before I delve into that, I would like to ask you if you have ever seen identical twins before. Have you ever seen identical twins? Identical twins look alike in every aspect, in their height, skin color, eyes, even dentition, that's arrangement of their teeth. You can hardly differentiate the twins. Identical twins develop from a single fertilized ovum or a woman's egg in the womb, and so are made of identical genes. Because they are developed from a single fertilized egg in a woman's body, they are made of identical genes, the same DNA. Even though identical twins look alike, their weights are always slightly different. No matter how they look alike, there will be something different. At least if you weigh the two twins, you will find out that they weigh differently, even though they are identical in every aspect. And also their fingerprints are also slightly different. This is because of some difference in the womb environment. But that's not our concern. Just like identical twins, it is isotopes also. They are atoms of an element, atoms of the same element, with the same atomic number, but different mass numbers. These are atoms of the same element, with the same atomic number, but different mass number. Just like twins are babies from the same egg, with the same skin color, everything, but different weights. Example of isotopes are, we have carbon-12 and carbon-13. These are carbon atoms. Carbon atoms, atoms of the same element, atoms of carbon. But if you watch, this one has the mass of 12, while this one has the mass of 13. Another example is hydrogen. Hydrogen has 3 isotopes. Hydrogen has hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 1 has the mass of 1, this one has the mass of 2, this one has the mass of 3. But they all have the same atomic number. The reason they have the same atomic number is because they are atoms of the same element. If you look at this structure below, these are structures of the 3 different hydrogens. Since we say that they have the same atomic number, why then do they have different masses? Why the difference in their mass number? You can recall in our previous video where we discussed relationship between atomic number and mass number. We said that mass number is equal to the number of protons plus the number of neutrons. Since hydrogen element, atoms of this atoms of this hydrogen have the same atomic number. That means they have the same proton. Then why do they have different masses if they have the same proton? Since mass number is number of proton plus number of neutrons, let's see what happened here. If you look at this structure of hydrogen, you find that in the nucleus you have only one particle there, and that particle is a proton. So this hydrogen 1 has only 1 proton and 0 neutron. It has no neutron inside the nucleus. Because of that, mass number, remember, mass number is number of proton plus number of neutron. So the mass number will automatically become 1 plus 0, which is 1. So the mass number of this hydrogen is 1. But if you look at this second hydrogen, you find out that it has 1 proton inside and 1 neutron inside the nucleus. And the mass number or atomic mass is number of proton plus number of neutrons. So we have 1 plus 1 to give you 2. That is why this hydrogen has the mass of 2. Then the third hydrogen, called tritium, has 1 proton, that's atomic number of 1. But if you look inside the nucleus, you find out that it has 2 neutrons. Because it has 2 neutrons, the mass will be proton plus neutron, which will give you 3. That is why this is 3, mass of 3. This hydrogen is called hydrogen, normal hydrogen. This is called deuterium. This is called tritium. But they are all hydrogen atoms. So you see that the difference in the mass number is caused by the difference in the number of neutrons. If you look at this other example, which is the chlorine 35 and chlorine 37, they all have atomic number 17, which means they have the same number of protons. But if you look at their masses, they are different. Why? Because the number of neutrons in these atoms are different. This one has 18 neutrons. How? Because the mass number is 35. If you use this particular formula, now mass number equals to P plus and N0. You will find out that if you make neutron the subject of formula, that's 35 minus 17 from here, you will have a neutron 18. So this one has 18 neutrons. Why this one has 20 neutrons? Because if you minus 17 from 37, you have 20 neutrons. Because of this, they have different masses, even though they are atoms of the same element. Mind you, what determines that an atom belongs to a particular element is the atomic number. This one is normal chlorine. Any element that has atomic number chlorine is atomic number 17 is a chlorine atom, no matter the mass. So the difference in mass number of isotopes is as a result of the difference in the number of neutrons. Okay, I would like you to look at this structure on the screen. This is the structure of, these are isotopes of carbon, sorry. If you look at these structures, you have carbon 12, carbon 13, carbon 14 with the same atomic number. I want you to look at this very well and figure out the number of neutrons in each of the carbon isotope here. Okay? Try it and let me see what you get. Now that you know that isotopes are atoms of the same element with the same atomic number but different mass number, if I ask you to go get me 1 mole of chlorine atoms in the lab, which will you get me? Which chlorine atom will you get me, since you know that we have different atoms of the same chlorine? To avoid this confusion, you see, you will be very confused. To avoid this confusion, scientists brought out a means of getting the relative atomic mass of isotopes of each element. And once you have this atomic mass, one single mass will represent the mass of all the isotopes of the same element. In our next video, that's what we are going to discuss. So I would like you to stay put and watch the next video. If you have any other question, you can ask me through email or Facebook Messenger or WhatsApp. Okay? Thank you for listening.